Hey, this video is to go over Unit 11 TUMs, that's Think Up Math. We're doing the questions in Unit 11 and Unit 14 if I have time at the end. All right, so for Unit 11, we're starting on page 111. And we're looking at Miguel. Miguel tosses a coin 3 times. The list represents the sample space of the tosses. Got Triple H, heads, heads, tails, heads, tails, tails, heads, tails, tails, heads, tails, heads, and so on. Which diagram shows the same information as the list? So I have 1, 2, 3, 4, 5, 6, 7, 8 different outcomes here. So I've got to have 8 different outcomes in my answer. This is 1, 2, 3, 4, 1, 2, 3, 4. So this has 8. This is 1, 2, 3, 4. This is 4. This is wrong. This has 4 and 4, which has 8. And this has 4 and 4, which also has 8. So now let's narrow down my choices again. I need heads, 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 and then heads, heads, tails. So this is heads, heads, heads. That's one combination. And then this is heads, heads, heads. This is wrong because I don't have 2 triple H's. Okay? I just have 1 up here, and here it is. So that's wrong. This is heads, heads, heads. This is heads, heads, tails. This is heads, heads, heads. And this is also heads, heads, heads. So this one's also wrong as well. My narrowed down choices leaves me with C. Okay, on to the next question. The list shows all possible outcomes for which experiment? Each experiment or trial or set of trials is in parentheses. So this is first trial and this is second trial. So I've got heads, 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 tails, 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 heads. What could I be doing? How many different things am I doing? Okay, my outcome is 4 results or 4 combinations. How many things am I doing per trial? This is a trial, this is a trial, this is a trial, and this is a trial. How many things per trial? That'll give me my answer. Number 3, Andy's little brother has a toy box that contains 2 blue race cars, 1 green race car, and 1 red race car. Andy removes 2 race cars from the toy box without looking. So these are all the cars in there. I've got 2 blue, a green, and a red. If Andy removes a blue car first and does not replace it, which best represents the sample space for the cars Andy removes? Well, if I'm starting off with the blue, I can do a blue and a green, a blue and a red. Let's see. Blue first, then green. That's pulling out 2 cars. That's doing 2 things. Blue and a red. That's pulling out 2 cars. That's doing 2 things. And I'm sticking along with doing blue first. If Andy removes blue first, can I take out a blue and a blue? Do I only have 1 blue here or do I have 2 blues here? I have 2 blues, which means I can take out 2 blues at a time. Blue and blue. Nadia has 2 pairs of jeans, 1 pair of khakis, and 2 pairs of black pants she wears to school. She also has 2 red shirts, 2 white shirts, and 1 gray shirt from which to choose. Nadia wears jeans and a gray shirt on Monday. If she does not wear a clothing item more than once during the week, that means she's not repeating anything. Which list represents the sample space for Nadia's outfit on Tuesday? I've got pants, 2 pairs of jeans, 1 pair of khakis, a pair of black pants. She already wore a pair of jeans and a gray shirt. Can I wear that gray shirt again? No. Can I wear that other pair of jeans again? No. But I still have another pair of jeans to consider. So I can wear jeans, I can wear khakis, and I can wear black pants. And with the black pants, I can have white shirt, gray shirts out of it, okay? I can have a red or a white shirt. Same with khaki, red or white. Same with jeans, red or white. All right, so that's white. You need to count all of your possible outcomes and then find an answer here that matches it. All right, page 112, number 1. Sarah draws a card from her standard deck. If the card is red, she rolls a standard die. If the card is black, she flips a coin. Which of the following tree diagrams correctly displays the sample space for Sarah's experiment? If I draw a red card, I need to think about what's on a standard die. That's 1, 2, 3, 4, 5, and 6. If I draw a black card, then I'm going to flip a coin. That's heads, and that's tails. I need to find an answer that matches these. I get 6 options for red and only 2 options for black. Number 2, Amelia receives a treat bag. The treat bag contains 10 gumballs, 5 pixie sticks, 2 bracelets, and 3 chocolates. If Amelia selects 3 items from her treat bag without looking and gives them to her sister, which could not represent a possible outcome for the items Amelia selects. Can I get 3 gumballs? Yes, I can because there's 10 of them. Can I get 3 pixie sticks? Yes, I can because there's 5 of them. Can I get 3 bracelets? No, I can't, but I can get only 2. No, 2 bracelets. Can I get 3 chocolates in a row? Yes, I can because there's 3 chocolates. So you need to go through your answers and find out which one is wrong. Which one is the wrong one? Number 3, a yogurt shop has a half-price mystery scoop special. The scoop could have vanilla or chocolate, yogurt. I'm going to write vanilla or chocolate. Van or chalk. And the toppings could be either hot fudge, caramel, or marshmallow toppings. So on my vanilla ice cream, I can get hot fudge, I can get caramel, or I can get marshmallow. And on my chocolate, I can get hot fudge, caramel. I'm talking about a whole different kind of yogurt. Caramel or marshmallow. Count the outcomes. Find, the match. Number 1 on page 115. Leroy knows that he will make an A, B, C, or D in his English class. These are his potential grades. If he makes an A or B, he will get a video game or $20 cash from his parents. So A or B, he gets a video game or $20. He gets a video game or $20 with a B. If he makes a C or D, he will have to do extra credit for the class or work with a tutor. C could be extra credit or tutor, and D could be extra credit or tutor. Which represents the sample space for the possible outcomes of Leroy's English class? Find out how many outcomes you have and then match them in your answers. Okay? plays a game in which she rolls 2 standard dice and finds the sum of the dots facing up. Which list shows all the possible outcomes for each roll of the dice? Okay, if I can roll a dice, I can get a 1, 2, 3, 4, 5, or 6. If I add them, I could get a 1, 2, 3, 4, 5, or 6. Boom, bam, boom, bam, boom. The smallest combination that I can get is 1 plus 1, which is 2. Not 1. I did 1 times 1. And the largest I can get is 6 plus 6 down here, which is 12, right above my think up word. So I need to go from 2 to 12. Okay? Which answer goes from 2 to 12? Don't forget that I have all of these in between. So this is 1 plus 1. This is 1 plus 2, which is 3. This is 1 plus 3, which is 4, 5, 6, 7. This is 3, 4, 5, 6, 7, 8. What are all the numbers going to be, or what are all of the numbers that are going to be in this box? That's your question. Or rhetorical question, but you'll answer it. It's not rhetorical, it's a real question. Anyway, number 3. The table shows Jason's choices of bread, meat, and cheese for his sandwich. In class, we should have discussed that when you get possible number of breads, meats, and cheeses, you're going to take each one. There are 2 different kinds of breads. There are 3 different kinds of meats, and there are 2 different kinds of cheeses. I am going to multiply them. 2 times 3, which is 6, times 2, which is 12. This is my total number of combinations. Okay? Which answer shows 12 combinations, and it's 1 bread, 1 meat, and 1 cheese each. Last page here. We are subtracting. Jill rolls 2 dice and finds a difference between the number of dots facing up by subtracting the smaller number from the larger number. List the possible outcomes for 1 roll. Again, if I have 1, 2, 3, 4, 5, and 6, and I'm subtracting them, I could say 6 minus 1, 6 minus 2, or I'm sorry, 6 minus 1 would be the biggest difference that I could make, and 6 minus 6 would be the smallest difference that I can make. I was right. 6 minus 1, 6 minus 2, 6 minus 3, 6 minus 4, 6 minus 5. This will be 5, 4, 3, 2, 1, and 0. So, subtract. And this will be your set. That goes here. That's what S is for. Set, sample space, whatever. Tom counted 12 socks in his drawer. 1 red, 3 navy, 5 black, and 3 white. Create a list to show the possible outcomes if 2 socks are removed from the drawer at the same time. Start with red. Start with navy. Start with black. And start with white. Who can be paired with each? After I say red and black, I can't say black and red again. It's a little fun fact. Black and red up here. Think about a deck of cards. And then what happens with an outcome of 1 through 6, or potential outcomes of 1 through 6, and potential outcomes of head through tail. If you draw a black card, then what are you going to do here? If you draw a red card, then what are you going to do here? Make a tree diagram here with dark and light. And then make a tree diagram here with red and blue. And then roll a standard die. That's 1 through 6. 1 through 6, red and blue. Okay, good luck. Show your work. Have a great day.